Let's do this, since I've already done the pretest, this is the rest of the period, this is what we're gonna do. But to make sure we get your questions answered, look at the front of page 4, looks just like the back of page 4, that we did in the video. What do I need to do? What do I need to start with? Make sure I get it covered before the end of the period. If you don't say something, I'm just gonna start cranking it through. So we want to look at number 2. So here are the problems in number 2. First one. Now we really would like to change this into that. So while it might seem a little bit counterintuitive, I think I'm going to change cotangent squared into what? What can I change cotangent squared into? Cosine squared over sine squared. And this is just cosine squared over 1. Now, having done that, what seems like a logical next step? You might want to do this on another sheet of paper. Get a common denominator, which will be sine squared. So now I have a denominator that is sine squared, and my numerator is cosine squared minus cosine squared sine squared. Now look at your numerator. Does anything occur to you that you could do in the numerator? You can cancel anything because of the minus sign. But can we factor? Can we factor? So why don't we do that? Let's pull out a cosine squared. And what will I have left on the top? If I pull out a cosine squared, I'll be left with 1 minus sine squared. 1 minus sine squared. And of course, what is 1 minus sine squared? So on the top, I have a cosine squared and another cosine squared over sine squared. Don't these two right here make a cotangent squared? So now we've got our cosine squared times our cotangent squared, which is what we were shooting for. Okay? All right, I got erased right now the next problem. Is everybody okay with that? So what were the steps again? We changed cotangent, got a common denominator, factored, notice that, and we have it. All right, how about B? What do you think we ought to do first with B? So change. There's a lot going on there. Okay. So you want to, you know what? I think before I get fractions, I'm going to go ahead and distribute. Is that okay? You might not want to do that, but is it okay to do that? Okay, so I went ahead and distributed. Now I'm going to do what you suggested. This is sine times cosine over sine. This is sine, cosine, and sine over cosine. Remember, you can't change sines and cosines, but you can change everything else. So my sines and cosine are going to stay the same. They're going to change. Now, what do I notice? Those cancel. And all I'm allowed to do that right here in this part of the problem because I most of them are easy. You just jump in and get started. Once you get started, you're not too bad. All right, next one. Cosecant plus secant. All right, so let's look over here. What do you think we ought to do first? Change cosecant into 1 over sine, and secant into 1 over cosine. Yeah. Now, hopefully, you're looking at that and saying, okay, I have your common denominator, which will be sine and cosine both. So this one needs a cosine, and this one needs a sine. Now they have the same denominator, so I can write them as one fraction. And the numerator will be cosine. Is that what I wanted? Easy peasy. Be brave, do not get psyched out. As the Bible says, be not afraid. All right, last one. I think this one's gonna be a challenge. We can do it. All right, so what do you want to do first? Sine over cosine. Plus 1 over cosine. Already have a common denominator, so now we're here. Oh, that is now at this point, you have to get creative because you can't change any of that. Sines are sines, cosines are cosines. If they were squared, I could change them. So maybe I'm going to multiply the top and the bottom by cosine. Now, the only reason, the credit where credit's due, the only reason that he suggested that is because if I have a cosine squared, I can change that into a sine. I can't change cosine. So he says, let's make this square. So to do that, we'll multiply top and bottom by cosine, which is completely legitimate. So now we have this. And what is cosine squared? 1 minus sine squared. So now we have cosine, sine plus 1, over 1 minus sine squared. What do we know about 1 minus sine squared? I just came from there, so I'm not going to go backwards. It's the difference of squares. So it is factorable. How will the denominator factor? The top does not factor. How does the bottom factor? 1 minus sine and 1 plus sine. These will cancel and all these will be left exactly what we wanted. That way, none of the other ones that we just made involved anything tricky. This one did. You had to recognize that you couldn't do anything at this point, so you had to change something. So he decided to change the cosine into cosine squared, and then that opened the door for us. That's tricky. All right, so that's part 2. Any other parts we need to look at? I think maybe 3 we need to talk about. I seem to recall that 3 is a problem area for some people. Are has been in the past. What does this mean? This direction right here, what does that mean?
Is it radians?
I got an answer in radians. This will be a no calculator problem, but B will be a calculator problem. This one is no. All right, look at it. You know what to do. What do we have to do first?
Change the 2x.
Change the sine 2x into whatever sine 2x is to sine cosine. That's off your reference sheet. Yeah, that has to be step one, guys. You gotta get rid of the 2x. Okay,
You subtract the cosine.
now we're gonna subtract cosine. Because we wanna have a 0. Now what?
Well, I would say back subtract the cosine on the left side.
They're not like terms.
Factor cosine.
Factor out a cosine. What will I have left if I pull out a cosine? 2 sine minus 1.
So minus cos 0 is.
And I set them both equal to 0. So my answers are gonna happen whether the cosine is 0 or where the sine is 1/2. Everybody keep up with that?
Yeah.
Alright. So 0 cosine 0, that's x. So look around our circle. Where is x? That's cosine. Where is x? 0. Pi over 2 and 3 pi over 2. Right, everyone? So, answers to that one are x equals pi over 2 and 3 pi over 2. Number around our circle, it's labeled like this. Now, where is the sine 1/2? Sine is y, and y is a positive number here and here. Opposite over hypotenuse. So this is √3. And how big is that angle? That right there, that's gonna be one of your answers. How big is that? It's 30, which is a sixth. So it's pi over 6. So is this one. This answer is pi over 6. But now we gotta figure out that answer. That one is pi minus pi over 6. So basically 1 minus a 6 is this 5 pi over 6. You're exactly right. This is 1 pi right here. So pi minus a 6. Anybody have a question about that? All right, I'm going to skip down to letter C, because it's another no calculator problem. And it is also in radians. All right, so we're going to do C. Then we'll come back and do B with our calculator. All right. This is very similar to what we just did. How are we going to start?
Cosine 2x.
Get rid of the cosine 2x. Now, this is the tricky one a little bit, because there are 3 versions of cosine 2x. We want the one that has all signs, because our problem has a random sign in it. So that one is 1 minus 2 sine squared. And then plus our sign. equation is that? Quadratic? Right? Personally, and I'm even a teacher, and I don't like to have quadratics with a negative x squared. So I'm gonna shove everything to the other side. So I'm gonna have 2 sine squared minus sine minus 1. It doesn't matter, but I know I'm going to factor, and I have a hard time factoring when that's negative. I shouldn't, it's kind of embarrassing, but I do. So I like to have everything positive, so I'm moving it, or have my x squared positive. So I'm moving it over, here I am. Remember, that's exactly the same as this. So I need a 2 sine and a sine. Obviously a 1 and a 1. One of them's got to be positive and one's got to be negative. Negative 2, positive 1. I think that's the combination I want. So this time, sine x equals negative 1/2, and sine x equals 1. Luckily, that's not my circle. Sine is y. Where is y 1? Straight up, pi over 2. So, and not 3 pi over 2, just pi over 2 this time, because we're positive 1. It's only up there. Where is sine negative? I need it to be negative 1/2. Where is it negative? The bottom. So here and here. And if the sine is 1/2, isn't that a pi over 6 angle again? Our answers are that one. Remember, that's pi. So that would be pi plus pi over 6. So it's 1 and a 6. 7/6. And then it would be that one, remember this is 2 pi. So that one would be 2 pi minus a 6. All the way around except for a 6. So 12 minus 1, 11 pi over 6. Along with pi over 2. So blue, red, and black, those are the answers to that problem. All right, now we're going to do B, and you'll, if you haven't already figured it out, you know why B is going to be a calculator problem. Do I need to do any replacements? Like here, I replace cosine 2x. I have no replacements here, it's all good. And can I just jump in and factor it? I think I can. So tan, if it bothers you, remember it's this. So how does that factor? Minus 5 plus 1. So tangent equals 5 and tangent equals negative 1. This is why you need your calculator. You can draw a picture of that. Where is tangent positive? That's 5 over 1. Where is the tangent positive? The first quadrant, where else? The third. Why is it positive in the third? because X and Y, adjacent and opposite are both negative. Look at the triangle, opposite is 5, adjacent is 1. Is that a triangle I know? No. So I need to go to my calculator, make sure I'm in degrees, because this was a degree problem, and do inverse tangent 5, and this is 78.69. Inverse tangent 5. So what are the answers, the actual answers? Is 78.69 an answer? Yeah. Be careful, not plus pi, actually I'm in degrees, plus 180, because I'm in degrees. So it would be 258.69. So if I am in radians on a problem like that, I'm adding pi. But if I'm in degrees, I'm adding 180. Okay? What about this one? Where is the tangent negative? 2 and, yeah, here it is positive. So that would be 2 and 4. This you actually know. You have a calculator, you can use a calculator. But if these are 1 and 1, what kind of angle is that if those are 1 and 1? That's a 45. But 45 is not an answer. What's that one? What's the red one? 180 minus 45, which is 135. And then how about the blue one? What is he doing? 360 minus 45, which is 315. And there are the answers to the problem. Remember, these are the questions, these are the kind of questions that are on your test. All right, so we practice 2 and 3. So we got 4, 5, 6. 1 is kind of different than 1. But basically 4, 5, and 6. So is there anything on there? Maybe should we do 60? Not because it's hard, but because we haven't really done very many. So we're just going to go 60. So it says, find the tangent of 2a. Stop right there. What's the formula for the tangent of 2a? 2 tan 1 minus tan squared. Yep. There it is. Write that down. Whatever the formula is, write it down. Now, it says A is in quadrant 2. It tells me that right there in the problem. And it says the secant is negative 5/3. So remember, secant is reciprocal of cosine. So that means hypotenuse over adjacent is negative 5/3. Hypotenuse never gets the negative. Do not put the negative on the hypotenuse ever. But 3 is clearly negative. Alright. So now we're going to do the Pythagorean theorem, which, once again, I rigged it. So it comes out nicely. 4, 3 squared plus something squared is 5 squared. They don't always work out so nice, but this one is. And it's positive. Now, here's the picture. There's the formula. Just plug the numbers in. So what's the tangent? In this picture, the tangent is negative 4/3. minus, do not cancel these negatives, because that one is getting squared out. So this is gonna be 1 minus 16/9. You gotta simplify it somehow. I prefer, when I do these problems, I prefer to multiply everything by the common denominator. So what's the common denominator of 3 and 9 and 1? 9. So I'm gonna multiply everything by 9. You do not have to do it this way, but you have to end up with my answer. Now, why did I do that? Well, this one's completely gone. This one cancels and leaves a 3. So now I've got negative 24 over 9 minus 16. So negative 24 over negative 7. Make sure, however you're doing it, that you get 24 sevenths.
So you could, what I did was, you could 1 minus.
Yep,
16.
absolutely. And then you change the, yep, you absolutely can do that. Completely, yeah. Is it emergency? We're gonna end in 5, or no, we're gonna end in 10 minutes, or 50. Is it an emergency? All right, take the pass and go.
Grid was always about
All right, so are we ready? Are we okay with that problem, 6B? Everybody follow those steps? All right, so what's left? Number 1 is actually just like that, so I'll just go through number 1 to make sure you're all on board with what I'm doing when I'm standing up here loud. What is the common denominator of this whole thing? X and Y. X, Y. So I'm gonna multiply this by X, Y, this by X, Y, this by X, Y, and this by X, Y. And you might be thinking to yourself, oh, good grief. But notice that now there are no little fractions left. It's just the regular fraction. So x squared y minus xy squared, multiplying these together, over,
Oh, wait, yeah, yeah.
it's y minus x. I think that actually might simplify. Do you see anything you might do with that? Don't say cancel because you got negatives in there and minuses, you can't do that. Notice anything about the numerator? We can pull out that x and y, and that will leave us with x minus y. Tell me what happens when you have x minus y over y minus x. They don't match exactly, so don't just cancel them out. But they are subtracted in the opposite order. And what did we say happens when things are subtracted in the opposite order? What if you had 3 minus 4 over 4 minus 3? What does that equal? That does not equal 1. Negative 1. When things are subtracted backwards, they will cancel. But they don't leave a 1, they leave a negative 1. So your answer is negative xy. So you might run into, like if you have cosine minus sine over sine minus cosine, you can cancel those out. Just make sure you cancel them into negative 1. All right, folks, we've got 4 and 5 and 6A left.
off plus tomorrow, dude?
No,
That's right.
I know.
Wait.
Tell me about it.
When's the test?
Huh?
We have a test next class.
Yeah,
So we'll have plus tomorrow.
over 5.1 to 5.4 on the, I did the practice test 2 video, and then we practice test right now. So, yeah, this is your chance to ask questions. Anybody see anything in 4, 5, or 6A that we need to talk about? 6A says find the cosine of 75. So, your job, there was one like this on the quiz. Your job, the first job is figure out from your list of special angles on your paper. And remember, hopefully you wrote down on your paper. We know 30, 60, and 45 are special. But that one day we made a list of the 30 in all 4 quadrants, the 60, and the 45. So there are actually 12 special angles that you have, okay, to use. So from those 12, you have to find 2 of them that either add or subtract, it doesn't matter, in the 75. So the most obvious is 30 and 45. But there are many, many, many other options, but those are the most obvious. Then, okay, so let's say we're going with 30 and 45. So that's U plus V. So I look at my sheet, and that's cosine U, cosine V, minus sine U, sine V. Once you figure out what your U and V are, then you're gonna find your formula and write it down. Then, we gotta plug in all of these. As long as your angles, your U and V that you pick are in quadrant 1, positive, 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 positive. But if you pick an angle like 150 to use, remember 150 is in quadrant 2. So that's going to be negative. So you might have some negatives inside your parentheses. We won't, because we're quadrant 1. All right. Cosine and sine are root 2 over 2 for 45. You can draw your picture, you've got it on your note sheet. It's fine, those will be the same, root 2 over 2. 30s. Hopefully you have on your sheet, or you just remember, that's a 30. So cosine is root 3 over 2. Sine is 1/2. They're both over 4. Root 6 minus root 2. And one thing to observe is when we do a problem like this, our answer is always something like this. All right, 4 and 5. Anything in 4 and 5 is perplexing. Sydney? 4C. All I have to do is, for all these problems, all you have to do is leave the numbers out for a minute, just say the letters. So it's 2 sine cosine. Find it on your paper where it says 2 sine cosine. That's sine 2x, right? That's sine 2x. So 2 sine cosine is sine 2x. Our x is 111. So this is the formula for the sine of 222. E is tricky. What's E? It's really easy, but it catches you off guard. 1. Sine squared plus cosine squared is always 1. Sine squared plus cosine. So E is 1. Okay, so Sydney, like problem 4B. I have a big radical, and I have 1 minus cosine over 1 plus cosine. What is that, the formula for? So it's tan angle over 2. What's my angle? 122. So this is the formula for the tangent. this is gonna be found on your sheet somewhere. What's my strategy for 5?
You know, it's cosine, you want to be so
Yeah.
spread it out.
So cosine 180, cosine x plus, it is, it was on your quiz, absolutely.
It's actually the same one.
This was the same question.
Well, because it's cosine was high.
Oh, okay.
But it might have been different.
So 180 is over here. So cosine is -1 and sine is 0. Because cosine is x and sine is y. So that's negative cosine and 0. And hopefully that's what I was trying to do. Yep,
And it wasn't the exact same, it was the same.
same idea. Okay. All right, well, that, take care of that. You've got a couple more minutes left, but you know what you need to do. We'll have a test next time. Tomorrow, we have office hours in the middle. We have them before school, but then we also have them in the middle of the day. If you want to swing by,